For number 6, to find out how many solutions this system has, you need to solve both equations. So what I did is I did it by substitution, and I took my second equation, I subtracted 2x, and I got y equals negative 2x plus 1. Then I substituted that back into my first equation, and I got 3 times the quantity negative 2x plus 1 equals negative 6x minus 3 halves. So when you distribute your 3, you get negative 6x plus 3 equals negative 6x minus 3 halves. Add 6x to both sides. They both cancel and become 0. So you get 3 equals negative 3 halves, which is not true, so you get no solutions. Number 7. At a movie theater, tickets cost $9.50 for adults and $60.50 for kids. A group of 7 moviegoers pay a total of $54.50. How many adults? How many kids? Set up a system and you must show your work. So the first thing I did is I said x equals adults, number of, and y equals number of children. We know that it's $9.50 for adults, $60.50 for kids. So I said 9.5x plus 6.5y equals the total of $54.50. Then they spent a total of, there was a total of 7 people. So we have x plus y equals 7. I thought because they're both in standard form, I did it by substitution. I thought, well, I'm going to go ahead and I'm going to get rid of my x, so I'm going to multiply both sides by negative 9.5. Whenever you multiply both sides by 9.5, you get negative 9.5x minus 9.5y equals negative 66.5. And we bring down our first equation, 9.5x plus 6.5y equals 54.50. Add the 2 up. They cancel. Negative 9.5 plus 6.5y is going to be negative 3 equals negative 66.5 plus 54.5 is negative 12. Divide by negative 3. And you get y equals 4. I substituted that in my second equation and said x plus 4 equals 7. Subtract 4, x equals 3. So you get 3 adults and 4 children. Number 8, because this is a dashed line, you know that it is either greater than or less than. It's a horizontal line, so it's y. So you have y is somehow related to negative 4. All of the y's shaded are above it, so y is greater than negative 4. Number 9, to tell whether 5 1/3 is a solution, you need to substitute it into both inequalities. To substitute it in the first one, you do 1/3 is less than or equal to. And then when you substitute in on the other side, you get 5 minus 4. So is 1/3 less than or equal to 1? Well, last time I checked, yes it is. When you substitute it into your second inequality, you have negative x, which is really negative 1 times x. So you have negative 1 times 5 plus 3 times 1/3 is greater than negative 4. Negative 1 times 5, you get negative 5 plus 3 times 1/3 is just 1. Is that greater than negative 4? Well, negative 5 is not greater than negative 4. Negative 4 is not greater than negative 4. It is negative 4. So because that is false, it is not a solution. Number 10. We need to graph these two, give 2 solutions that are 2 that are not. But first we need to put them in slope-intercept form. For my first inequality, we have y minus 3x is less than 5. Simply add 3x to both sides, and you get y is less than 3x plus 5. My second inequality is a little bit more challenging that you have 3x minus y is greater than or equal to 7. So you have to subtract 3x from both sides, and you get negative y is greater than or equal to negative 3x plus 7. But remember that negative y is the same thing as negative 1 times y. So when you divide both sides by negative 1, you get y is now less than or equal to. Make sure that you flipped your inequality. That is really, really, really important. To positive 3x minus 7. So let's go ahead and graph this. The first one has a y-intercept of 5, so we go up 1, 2, 3, 4, 5. And you have a slope of 3, so you go up 1, 2, 3 to the right 1. Down 1, 2, 3, left 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 1. And because it's just less than, we have a dashed line. And let's try 0, 0. Is 0 less than 3 times 0 plus 5? Well, yes, 0 is less than 5. So we know that we want to shade below this line. Our second one, we have a y-intercept of negative 7 and a slope of 3. So go up 1, 2, 3, right 1, up 1, 2, 3, right 1, up 1, 2, 3, right 1, up 1, 2, 3, right 1. And connect with a solid line this time. If you tried 0, 0 here, is 3 times 0 minus 0 greater than or equal to 7? Well, no, 0 is not greater than or equal to 7. That's false. So we don't want to shade where 0, 0 is. We want to shade on the opposite side. So we'd shade over here. So where you see your purple and your blue, this is where all your solutions are. So I'm just going to name two simple ordered pairs over there. Oh, how about 6, 0 and 7, 0? They're both over here, 6, 0, 7, 0. And not solutions, well, 0, 0 wasn't one. Negative 10, 0 was not one. So that's how I got my answer. Number 11. It's like a little riddle. The difference of two numbers is 13. When twice the first number and 3 times the second number are added, their sum is negative 14. What are the two numbers? Well, first, I just set up and said that x is my first number and that y equaled my second number. The difference means subtraction. So the difference of two numbers, you have x minus y equals 13. When twice the first, so 2x, and 3 times the second are added, plus 3y, the sum is negative 14. Because I have a positive and a negative here, I thought I'll eliminate my y's, and I'll just simply multiply the first equation by 3 to get 3x minus 3y equals 39, and I still have 2x plus 3y equals 25. So when I add the two equations up, my y's became 0, and I have 5x equals, this is negative 14, because when you add them together, that's where you get your 25. Divide by 5, and you get x equals 5. I substituted in the first equation because I thought it was easier, it was more simple. And we have 5 minus y equals 13. Subtract 5, subtract 5. Negative y equals 8. Divide by negative 1, and you get y equals 8. So you'd say your first number equals 5. Your second number equals 8. Negative 8. Number 12. Andrew earns $10.75 per hour and already has $686.40 in his account. Starling earns $12.40 an hour but doesn't have any money in his savings account. If the wages continue, will Starling's account ever equal Andrew's? If so, after how many hours? So the hint is to first define our variables. We know that we're trying to find the total amount of money and the number of hours. Your total money depends on the number of hours. So that's why y is total money. For Andrew, we know that his total money comes from the fact that he earns $10.75 an hour plus that fact that he already has $686.40 in his account. For Starling, he's only making $12.40 times the number of hours. He doesn't have anything to add on to it. So I used substitution, and I got 1075x plus 686.4 equals 12.4x. Then I went and subtracted 10.75x minus 10.75x. 12.4 minus 10.75x is going to give you 1.65x equals 686.4. Then math magic happens. When you divide by $1.65 or 165, you get 416 equals x. So the answer is yes, they do in 416 hours. Number 13, you have to know the formulas for perimeter and area for number 13. It says Maureen has 16 yards of lumber that she can use to fence in a play area for her dog Ellie. Write and graph a linear inequality that describes the length and width of the play area. So I'm going to stop there for a minute. If we know that this is her play area, when we are talking about the fencing, we're talking about the perimeter. You must know that perimeter is 2 times the length plus 2 times the width. You have length, length, width, width. So you know that she only has 16 yards. So her maximum perimeter can be 16. That's her maximum. That's all she has. So 16 is the maximum that she can have. This is what she's using over here. 16, since it's the maximum, it has to be greater than or equal to 2 times the length plus 2 times the width. Because it's the max it can be. Let's define that L equals length and W equals width. I'm just going to go ahead and rearrange it so I have 2W plus 2L is less than or equal to 16, just because I like to have my variables on the left. And notice open end 16, open end 16. The easiest way to graph this one, because it's in standard form, is to go ahead and find the 2 intercepts. Let's find the width intercept and the length intercept. Remember the cover-up method? You simply cover up the L, and you have 2W is less than or equal to 16, divide by 2, divide by 2. You get W is less than or equal to 8, so your width intercept is 8. Do the similar thing with your length. 2L is less than or equal to 16, so L is less than or equal to 8. Your length intercept is also 8. So go over to your graph, and your length intercept of 8, your width intercept of 8, and since it's less than or equal to, you know it's going to be a solid line. So we go ahead and just connect our solid line. Nice in there. Now let's think about what side to shade. I'm going to try 0, 0 out. So is 2 times 0 plus 2 times 0 less than or equal to 16? So essentially, is 0 less than or equal to 16? Yes, that is true. So I'm going to shade everything in here. So these are all the different possible combinations that would work. Now that we've done the first part, now we can take a look at the second part of this, the word problem. It says, if Maureen wants the dimensions to be whole numbers only, what that means is she does not want a length that's 2.5. She doesn't want that. She wants 2, 3, 4, something like that. What dimensions would produce the largest area? So we know we have length, we have width, and area equals length times width. So if I take a look in my triangle, I could say, well, she could have a 2 by 2, and her area would be 4 yards squared because it's in yards. Well, but that's not really that big. What about a 4 by 2? She has a 4 width and a 2 length. Oh, we have 8 yards squared. But look at everything on the line's a little bit bigger. What about a 4 by 4? You get 16 yards squared. That is way bigger. And if you substitute those in, you have 2 times 4 is 8 plus 2 times 4 is 8. That equals 16. It's not going to get any bigger. So you have a 4 yard by 4 yard. It is a square. A square produces the largest area. If you don't have a perfect square like 16, you would just pick values that are the closest to a square, like a 4 by 5, a 6 by 7, a 9 by 10.